Guys, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Asri from Group 4, Lab Control, Section 2 for Electronic Engineering Lab 2, whole system lab. So, our group consists of Louis, Ishraf, my name is Muhammad Ashraf, and Daniel. Okay, so for the abstracts, transmission lines are critical component of power transmission system, but their performance can be impacted by a range of physical phenomena. To optimize design and last performance and make informed decisions about maintenance and upgrades, engineers use mathematical models to simulate the flow of electricity and predict the behavior of system under different conditions. MATLAB is a popular software used for modeling transmission lines. In this report, we will provide an overview of the basics transmission line modeling using MATLAB software, including the key principles, techniques, and applications of this powerful tool. Aim to comprehend the modeling and performance of transmission lines of various lengths, short, medium, and long. So, for the introduction, transmission lines are crucial for efficient and reliable transfer of electrical power over long distance. However, they are subject to various physical phenomena such as capacitor inductance, resistance, and frequency-dependent losses. To predict the behavior of the system under different conditions, engineers use mathematical models to simulate the flow of electricity through the transmission line. MATLAB is a popular software used for modeling transmission lines, which allows engineers to analyze the performance of system, optimize its designs, and make informed decisions about maintenance and upgrades. In this lab, we will explore the basic transmission line modeling using MATLAB software. Transmission line can be classified based on their length and characteristic of the line. The three main classifications of transmission line are short transmission line, medium transmission line, and long transmission lines. Short transmission line are typically less than 80 km in length and have negligible resistance, which means that the voltage at the sending and receiving end of the line is almost the same. The capacitance of the line is significant, which can cause voltage drop and losses in high-speed lines. Medium transmission lines are between 80 to 250 kilometer in length and have moderate resistance and capacitance. These lines are designed to provide efficient power transfer over moderate distance, and engineers must take into account the line impedance and the characteristic of the load. Long transmission lines are typically more than 250 km in length and have significant resistance and capacitance. The voltage at the receiving end of the line is lower than the voltage at the sending end due to line losses. The engineers must take into account the line inductance and capacitance to optimize power transfer efficiency. Okay, next I will give to my team members to explain about method. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Hafiz bin Sulaiman, DE210044. Okay, I will continue for the methodology. Okay, for the methodology, MATLAB program codes that were used to compute the outcome from a certain exercise. The code are pasted into the editor and saved as and file types for each exercise based on the historical information provided in the exercise. Each program has a unique input and output. Okay, for the question 1, this is for the analysis for the coding that have been given in for the question. Okay, this is for the process. The process is the calculation for the VR, Z, IR, IS, VS, VSS, VSLL, SS, RED, and also EFF for the efficiency. Okay, the output we have two parts. For 0.8 power factor lagging, it will display the value of IR, VSLL, SS, RED, and EFF. For the 0.8 power factor leading, will display the VSLL, SS, RED, and EFF. Okay, this is for the flowchart. It will start and calculate, and it will display for the output for the A part. for 0.8 power factor lagging. And this is for the process. It will display the value of IR, also the process, and after that it will display for the output for B part for 0.8 power factor leading. It will calculate the SR, IR, IS, BS, VSLL, and it will display the value of VSLL, SS, and also EFF, and then it will end the process. After that, for the question 2, we have 3 part: input, process, output. KM for the input, VW power factor, L, RNC. Okay, for the process, yes, many process, yes, many calculation. You will find for the I, VRP, PF, LR, CV, CZY, A, B, C, D, IR, VR, VS, VSL, VS1, IS, right, POW, EFF, VRNL, PCR. Okay, for the output, it will show the line kilometer, receiving voltage, power factor, L, RNC, output medium, display output of generation of ABCD constant, IR, VR, VS, and voltage VS, VS1, IS, VS, and power and current IS, regulation POWS, AFF, PACR, and also sending end power. Okay, this is for the flowchart. It will start from the beginning, and we have to input the value from here, and it will calculate using the code that have been given, and it will display the output medium. This for the question, and it will calculate more and display the output of ABCD constant. Okay, after that it will calculate and display the value of IR, VR, VS, and so on. Display the value of VS1, IS, right, and also calculate, and the last one it will display the PNL about sending in power, and also at the end. Okay, for the question 3, it also have 3 input, process, and also output. Okay, the input is B, S, SB, RB, and PLC. For the calculation, this for the calculation, and also it will output the display output of bus admittance matrix. Okay, this is for the flowchart. Start, input, calculate, input, operate, and lastly it will display all the bus emitter matrix, and the end. Okay, that's for me. I will pass for the next simulation to my friend.
Very good day to lecturer and friends. Today I will talk about the result and how to get the result from the method. So first we need to study the question here. After we study the question, so better we need to put the data from here. So after we study the question, go to the manual calculation. So manual calculation we have to study. Later we need to compare the result from the coding here. So after we put inside the coding, it's with the method I already put inside here. So after you run, you will get the result here, or the result here. So we need to compare all the results here so that whether it's matched or not. So we need to check one by one. If the result is matched, so means that the program one that is successful. Next, we continue with the program 2, that is medium condition line. As usual, we need to study the question here because the data we will entry into the method. So after we study the question, we continue with the manual solution. So we study one by one, can check the manual calculation, whether it's correct or not. So later on, we need to put the coding inside the method. Because this program tool have some problem on this coding, so we change a bit on the coding. So after we change at the front there, we change the coding, and then we put inside, we type it, one by one. So the coding is like this, a bit different from the back. So after that we run. Then we need to enter the data. The data are from the question. So the first is 200, 132, 50, 0.8, 1.29, 52, 0.0. After we enter the data, and then we will enter it. So we will get all the result here, but I need to check one by one from the nugget here, from the nugget here, and then the calculation, and then we compare it. If the result is matched, so means that the program is successful, because the result from the nugget have a bit different, so it's look like successful because it have a bit of the error. So now we continue with the program tree is the y bus matrix. So as usual, we need to see the question, and then we study it, and then we follow by the program plugin. So we put inside the plugin here. Okay, wait, we click here first. After we put inside the plugin here from the sheet, so we run. Then we need to enter the data from the lab sheet just now. Okay, so we go it one by one. So the number of bars is 3. Okay, open the okay, open the lab here. So 3. So number of integers also 3. And then starting from 1 and receiving by 2. And then the evidence is 0.1 plus 0.3. So we continue. Line charging admittance is 0.02. All the data are in the question. So let's continue. The next one is starting from 2 and receiving by 3. The third one is 0.15 plus 0.53. The on 0.0125. Then continue. Starting from 3, receiving by 1. The impedance is 0.2 plus 0.6G. Then the line charging is 0.0288. So we enter all the data and then we enter it. So we will get the metric form like this. So this is the result from the program tree. So I will continue with the discussion of this lab. So from the lab, we learn how to conduct the lab by using MATLAB, and also how to edit the coding so we can get the same result in the lab. So in the lab, we found some problem in coding too. So we need to change the coding so that we can get the result for the program sent with the backsheet. And then each of the program is related to each of the questions. We also learn about the short transmission and medium transmission line, and also how to calculate the matrix for the program tree. So other than that, we also know how to analyze the question and then key in the data. Recommend that we need to know and analyze the question and we need to analyze the data so that we can entry the true data so that we will be get the true answers. So the coding also need to be analyzed that we know what value we need to key inside in the command window. So that's all. Thank you.
In conclusion, I learned how to run experiment and analyze outcome using MATLAB. We practice calculating matrices and work with short and medium transmissions line. We also practice altering the code to produce accurate results and appropriately entering data into MATLAB. When performing tests, I discovered that paying attention to details is critical. We came into some code challenges with program 2, but we were able to analyze and remedy the problems. This experience showed me the value of analyzing outcomes and detecting potential code bugs. Overall, this lab gave me hands-on experience handling real-world problems and aided in the development of skills that would be available in my future studies and employment.